Hello, I am Fathima Raniya, 4th Sem Computer Science, and I'll be taking a seminar on flow control in data communication and optical fibers. Flow control. Flow control refers to a set of procedures used to restrict the amount of data the sender can send before waiting for acknowledgement. So, flow control is nothing but a set of procedures or a set of steps which is used to restrict the amount of data the sender can send before waiting for an acknowledgement. So, before a sender can send an fact or an acknowledgement about the data to be next sent, these procedures are called the flow control. So flow control are of two types: stop and wait and sliding window. In stop and wait, we can send one frame at a time, and in sliding window, we can send several frames at a time. Methods to control flow of data. There are two methods which is developed to control the flow of data. They are stop and wait and sliding window. Stop and wait. The sender waits for an acknowledgement after every frame it sends. Only when an acknowledgement has been received is the next frame sent. This process of alternately sending and waiting repeats until the sender transmits an end of transmission EOT frame. So here, as we have already discussed, we can only send a frame at a time. So the sender waits for an acknowledgement after every frame it's sent. So each frame it is sent, the sender will have to wait for the acknowledgement. Only when an acknowledgement has been received is the next frame sent. So after the sender sends an frame, they will have to wait for the acknowledgement so that it can send the next frame. This process of alternately sending and waiting. So here what is happening? The sender is sending and then waiting. So the step is sending and waiting repeats. So these procedures continue until the sender transmits an end of transmission frame. So until this process continues until the sender gets an EOT or the end of transmission frame. So now let's look on to the advantage and disadvantages of stop and wait. The advantage of stop and wait is simplicity. Each frame is checked and acknowledged before the next frame is sent. So here the advantage is simplicity. That is, we said that after every frame is sent, we will have to wait for the acknowledgement. So every frame is checked here. The disadvantage is inefficiency. Stop and wait is slow. So the disadvantage is that it is inefficient. We'll stop and wait is slow because we have to wait after each frame is sent. Each frame must travel all the way to the receiver, and an acknowledgement must travel all the way back before the next frame can be sent. So the each frame or the each data have to travel all the way to the receiver, and we will have to wait for the receiver to come back with the acknowledgement. So this is a diagram of a stop and wait. So we have a sender and we also have a receiver. So the sender first sends the data to the receiver. Now the receiver sends back the acknowledgement. So this time period between the data is sent and the acknowledgement is received is called the wait time. So this process undergoes repeatedly until the EOT. Next is sliding window. The sender can transmit several frames before needing an acknowledgement. The receiver acknowledges only some of the frames, using a single acknowledgement to confirm the receipt of multiple data frames. So, unlike the stop and wait, the sliding window can transmit or can send several frames at a time before needing an acknowledgement. So, here they don't want an acknowledgement after each frame is sent. The receiver acknowledges only some of the frames. So receiver only acknowledges some of the frames, not every frames, just some of the frames, and uses a single acknowledgement. They only use a single acknowledgement to confirm the receipt. Okay. The sliding window refers to imaginary boxes at both the sender and the receiver. So what is sliding window? It refers to the imaginary boxes at the both sides, that is the sender and the receiver. This window can hold frames at either end and provides the upper limit on the number of frames that can be transmitted before requiring an acknowledgement. Frames may be acknowledged at any point without waiting for the window to fill up and may be transmitted as long as the window is not yet full. So here, the frames can be or may be acknowledged at any point through the sending, okay, without waiting. There should be no waiting for the window to fill up and may be transmitted as long as the window is not yet full. Okay, so the data can be transmitted as long as the window is not full. The frames are numbered modulo n, which means they are numbered from 0 to n minus 1. For example, if n is equal to 8, the frames are numbered 0, 1, 2, 3, 4, 5, 6, 7, 0, 1, 2, 3, 4, 5, 6, 7, 0, 1, 2, 3, 4, 5, 6, 7, etc. The size of the window is n minus 1. So we got n is equal to 8. So here the size of the window is n minus 1, which is equal to 7 in this case. In other words, the window cannot cover the whole module. It covers one frame less. Okay. So we can say that the window cannot cannot cover the whole module. It can just cover only n minus 1 frames, that is 7. It covers one frame less. When the receiver sends an acknowledgement, it includes the number of the next frame it expects to receive. So in this case, in the sliding window case, after many frames are sent to the receiver sends back an acknowledgement at any point of time. Okay, not after every frame. It sends back an acknowledgement at any point of time, and it includes in this acknowledgement it includes the number of the next frame it expects. Okay, how much frames it is going to expect is sent in the acknowledgement. In other words, to acknowledge the receipt of a string of frames ending in frame 4, the receiver sends an acknowledgement containing the number frame. So here we took an example where n is equal to 8. So after the fourth frame is sent or fourth string is sent, it replies back an acknowledgement telling that it is expecting about 5 frames. When the sender sees an acknowledgement with the number 5, it knows that all frames up through number 4 has been received. So when it receives back that there is 5 frames it is expecting, it knows that all frames up through number 4 have been received. The window can hold n minus 1 frame at either end. So we said that before, that the window can hold n minus 1 frames. Therefore, a maximum of n minus 1 frames may be sent before an acknowledgement is required. So, maximum of n minus 1 frames. So, here we can send maximum of n minus 1 frames before an acknowledgement is again required. Next is sender window. At the beginning of a transmission, the sender's window contains n minus 1 frames. So we already said that sender's window. Now we are looking on the perspective of the sender's window. There will be n minus 1 frame. As frames are sent out, the left boundary of the window moves inward, shrinking the size of the window. Once an acknowledgement arrives, the window expands to allow in a number of new frames equal to the number of frames acknowledged by that acknowledgement. So after once an acknowledgement is arrived or received, the window expands to allow in a number of new frames. So after acknowledgement is received, it expands to allow number of new frames equal to the number of frames acknowledged by that acknowledgement. That is, we said that it will acknowledge a number of frames it is going to expect. So that number of frames will be expanded. That is, the sliding window of the sender shrinks from the left when frames of data are sent. The sliding window of the sender expands to the right when acknowledgements are received. So, when the frames are sent out, the left boundary of the windows move inwards, shrinking the size of the window. But when the frames of the data are sent, the left will be shrinked. The sliding window of the sender expands to the right when acknowledgement are received. So when it is sent, it shrinks the size of the window in the left side, but when it is received, it expands the right when acknowledgement are received. Now, on the perspective of receiver window. At the beginning of transmission, the receiver windows contains not n minus 1 but n minus 1 space for frames. In the receiver side, there is no n minus 1 frames, but it contains the space for the n minus 1 frames. As new frames come in, the size of the receiver window shrinks. So, as each and every new frames are coming in, the receiver's window shrinks size. The receiver window therefore represents not the number of frames received, but the number of frames that may still be received before an acknowledgement must be sent. So, the receiver window, what it represents, the receiver window represents that how many space is there for more frames to be received. Okay, so that it can send the acknowledgement. As soon as an acknowledgement is sent, the window expands to include the places for a number of frames equal to the number of frames acknowledged. So once the acknowledgement is sent to the sender's window, it expands the space for the number of frames on how much it have been sent in the acknowledgement expected. That is, the sliding window of the receiver shrinks from the left when frames of data are received. The sliding window of the receiver expands to the right when acknowledgement are sent. So here, sliding window receiver shrinks from the left when frames of data are received, but it expands to the right when the acknowledgement are sent. So that's all about flow control in data communication and optical fibers. Thank you.